This video is on another linear algebra concept that will get used in the assignment. Consider a plane spanned by two vectors, a1 and a2. And consider a third vector that is not in this plane, called b. The question we're trying to answer is, what is the closest point to b on the plane spanned by a1, a2? To find this closest point, let's draw up a perpendicular from B onto that plane, and where it hits the plane, we'll call that vector C, as shown in the figure that's coming up. Drop the perpendicular, and that vector is C. Now, because C is on the plane spanned by A1 and A2, it's got to be a linear combination of A1 and A2. So let's make a matrix whose columns are A. Then C must be A times X, which is a linear combination of A1 and A2, for some 2 by 1 vector X. So let's redraw the picture. We've got the two basis vectors A1 and A2. We've got the B, the perpendicular, and C is now A times X, and the difference is B minus AX. And we see that the vector B minus AX must be perpendicular to every vector on the plane spanned by A1 and A2. Only then is C the closest point. So any vector on the plane can be written as A times Y for some 2 by 1 vector Y. So we're saying that the dot product of A times Y and B minus AX must be 0 for any Y, which we can also write like this. And using our relationship for transpose of a product is the product of the transpose in the opposite order, we can write it like this. And because this is true for any Y, A transpose B minus AX must be 0, and we can write it like this. And A transpose A is a square matrix, so we can solve for X like this. In MATLAB, this can be done very simply as just X equals A backslash B. Although MATLAB doesn't actually compute X when we do A backslash B using the formula above, it does something much better and different. But X, the closest point, can be computed by just doing A backslash F. So when A is square, A backslash B solves the equation AX equals B. When A is not square, A backslash B computes a vector X such that A times X is the closest point to B in the space spanned by the columns of A. That is, the distance B minus AX is the smallest. Or in other words, the distance B minus AX is minimized. So this is a summary of what the backslash operator means in MATLAB. We can also say that B is orthogonally projected onto the plane spanned by the columns of A. We'll see in the next video where this gets applied in the assignment.